So here we are, day 2 in Frankfurt, Germany for Formnext. We're at the Polymaker booth with Luke here. Luke, how are you doing today?
Very well, thank you, Sam.
Excellent. Obviously, we talked a little bit yesterday about the new spools that are fully recyclable. In fact, let's talk about that for a minute.
So,
what goes into this?
Yeah, so this is the new spool. Talk about some of the design features on the new spool. We have a 4mm thick cardboard outer face, which is solid cardboard. It is die cut, so it's very round, which means it rolls on bearings very nicely and on all spool holders, internally and externally. But the best part about the new spool is its afterlife. Tear it apart easily, straight in the recycling bin, and no more building up piles and piles of plastic spools.
I'm really glad that ripped as easily as you thought it would do. That's great though, isn't it? That's great. What about looking at things like reuse? Could you reuse that spool potentially?
If you don't rip it apart, yes you can.
We're certainly not going to be gluing that one back together. Let's talk about Filament. Yesterday we were talking obviously about cardboard spools and your innovation around that. Let's talk about PLA, Polyterra.
Yeah, so Polyterra we launched in February, and we wanted to make a more environmentally friendly PLA material. So the big part about Polyterra is we have matte surface finish, and we're planting one tree for every spool that we sell. And the tree will be planted locally to the point of purchase.
Wow, okay. That's amazing. That's amazing.
Since February, we've planted over 90,000 trees, and we don't plan on stopping. So every, after 4 years, the tree will have matured enough that it can suck in about 20 kilograms of carbon dioxide each year. It takes about we produce 4 kilograms of carbon dioxide to produce the filament and ship it around the world. So after about 2 or 3 years, the product becomes carbon negative.
Wow, that's incredible. I didn't realise you'd gone that in depth. I know we were talking about cardboard spools yesterday, but I mean that's next level stuff. That's really well thought out. So look, let's look at some of the new colours that you guys have just produced. What have we got?
So this model here is the flying sea turtle. This actually has all 4 of our new colours that are available in Europe. In North America there's even more colours available, but this is an army series of colours. So we have army brown, light brown, this dark green, actually my personal favourite, and the army light green. And here we have the flying sea turtle model.
That's awesome.
Whenever
that's
you feel
really
sad,
cool. Yeah.
Let's play with the sea turtle.
You need to automate that. It needs a motor on it, surely.
Yeah.
Fantastic. So what's the range then? So do you know all the colours?
I do. I named them all.
Should we go through them?
I do.
Go for it.
Okay, so we have charcoal black, sapphire blue, sunrise yellow, savannah yellow, sunrise orange. This is coral red. This is fossil grey, cotton white, forest green, Polymaker teal, or arctic teal, sorry. Lavender purple, this is rose, this is mint, candy, peach, banana, this is a new one, this is ice, this is sakura, and then army dark green, army light green, army light brown, army dark brown.
That's incredible. My favourite certainly is the teal, as you know, which is kind of like the Polymaker colour as far as I'm concerned. Fabulous. So let's look at some of the... Okay, Luke, so what have we got here?
So this is really Polymaker. This is our bread and butter engineering materials. This is what we became famous for, I think. So starting here, we have our nylon. This is our basic nylon. It is a copolymer, a blend of nylon 6 with nylon 6/6. We take the high heat resistance from 6/6 and the high strength from 6, blend them together into a copolymer, and it also prints completely warp-free, so no enclosure. Only a heated bed of 60 degrees.
Really?
And you can print, big gears, warp-free. This is printed on the Taz, and it has it's perfect for gears. Nylon, obviously, very popular material for making gears anyway.
Absolutely.
Because of its wear resistance. This is an oar connector.
Right.
Actually,
yeah.
From my dinghy.
Wow.
I was paddling down the canal one day, and my oar connector snapped, and I was literally stuck without a paddle. And so I carried this one up, and it's been good ever since.
Printing new ones. So, I mean, what I'm seeing at the moment is, we're going from the PLA and the PET Gs and, all the kind of consumer prosumer styles Well, certainly what I'm interested in right now is, how do we evolve from that and make proper gearboxes? And you know that certainly on the big the Poly XL robot that we were doing recently, I used PC, I used a lot of different materials inside of that to try and ensure that the motors were going to be strong enough, obviously, to turn the drivetrains. When you've got things like with Matt, is Matt just using PLA and PET, or is he using nylons? Is he...
Yeah, I think so. Matt is for the smaller stuff, he's using just PLA and PET. For the big go-kart, he's doing gears in nylon.
Right.
There's a lot more torque going through there. The belts are generating a lot more heat. The copier has a softening temperature of 180 degrees, so you can get it really hot without it failing. It also has a little bit of flexibility, which helps with the meshing of the gears.
Right. Oh, that's great. That's great. So what else do we have here? What's this material? This looks awesome.
So moving up, this is PA6CF. This is a 20% carbon fiber reinforced PA6. It is by far our best performing material. If you have a look at our material charts, it wins everything in terms of strength, stiffness, impact strength, and it has the highest heat deflection temperature also. The problem is, it is a little rougher surface because it has 20% fibers inside.
Sure.
And a little bit more expensive because of the extra fibers in there.
So moving down the line a little bit now, Luke, what do we got here?
So this is the latest one. It's a PA12 CF, so it has the longer polymer chain, and what that means is it's got better printability. So you see the surface quality is much better than the PA6.
Yep.
One, because it has less carbon fibers, and two, because it absorbs less moisture from the atmosphere and it's just easier to print. So you can have a spool, you can print a couple parts, you can take it off, you can leave it a month, you can come back to it, and it's going to be exactly the same.
Really?
Whereas the PA6, you're probably going to have to dry it, or you're going to have to store it in a very special environment,
And was this the material we were talking about technically yesterday?
Yes.
Right,
So the
gotcha.
PA12, the longer polymer chain, it can absorb less moisture because there's less room for the moisture to get in.
Great.
Whereas the PA6, shorter molecule chain, more room for moisture to get in, but in the end you get a tougher material. So do you need printability and reliability, then PA12 is better. If you need just outright strength, but you're going to have some other storing issues, and then PA6CF is better.
So in regards to the strength there, what kind of applications do you think people are going to be using this type of stuff for?
So one application we have here is it's a steering wheel mold and a steering wheel inner core. So you print the mold in PA12 because you want a nice surface finish, and then you print the inner core in PA6CF, and then you wrap one layer of carbon fiber around the core, vacuum the whole thing, and you can bake it in the oven at most resins cure about 120. Right. The heat resistance is good to up to 200.
Amazing. So Luke, let's talk about your glasses for a second. I have noticed them. I'm normally a glasses wearer myself. Contacts in today though, due to mask steaming. Tell me a little bit about your glasses.
Yeah, so these are my 3D printed glasses. They are printed in Polymatte PLA, our black Polymatte. It's a lightweight pre-foamed PLA, so the actual plastic of the glasses very, very light. Most of the weight is just the lens and the hinges. And they feel really nice, and the best part is if you ever sit on them, you can just reprint them.
Yeah, well, I'll tell you what, they do look very stylish. So Luke, I've just noticed this one. What is this particular material?
This is the last one in the Polymide family. It's a PA6 but with glass fibers instead of carbon fibers, and you lose a little bit of strength compared to the carbon, but it's much more affordable and a very stiff material. I think for many, many applications, this PA6GF is far easily strong enough, I think.
So Luke, last but not least, what do we have here?
So this is our Polylite family of materials, just really high quality, really reliable, good filaments. You see here the extruder from Lulzbot is made all out of our Polylite PETG. Yep. Also material you're using for your robots. It's offers a little bit more than PLA, but still printing really nicely.
So a fun fact, of course, is the Lulzbot Sidekick is printed, 50% of the printer is printed with Polymaker filament, right?
Yeah. I think all printed parts.
Yeah. It's amazing. Yeah, absolutely amazing. So it must be a proud achievement for your material to be chosen for that kind of application.
Yeah, we've had a really good relationship with Lulspot ever since the beginning. We like them. We like their open source mentality. They're happy to share these kind of things with the public. You know, not many people would tell the public, oh yeah, we're using Polymaker material to print our parts, but I think maybe for them it can build some confidence in their customers and in their parts.
Yeah, I totally agree. So what else do we have here? I'm seeing, this is one of my favourites, this is obviously the TPU. This feels, and is it the 90?
That is a 95.
Oh!
You've been fooled by the gyroid.
I have, you're quite right.
This one is actually the high flow. It's,
right.
It has a higher melt index than PLA. So you can print this one. This model here is printed at 100 millimeters a second. On an indirect extruder.
Wow.
So, you know, TPUs always, you've got to slow them right down. Prints end up taking ages and ages. This is a high flow TPU, you can print just as fast as all your other prints.
That's insane. What else do we have here?
This is personally my favorite model. It is the barbecue, ASA barbecue fan. ASA, great for weather resistance, UV, stability, heat and water. So you have a barbecue fan, it's got a planetary gearbox in the back.
Amazing.
And it's really tactile, really fun to use, really nice model. And yeah.
What's on that particular material then, what's the heat? What's the heat charge there? How hot can you get that before it starts causing problems?
Yeah, so softening temperature is about 100, 101 for ASA.
Okay.
So very similar material to ABS, they share two monomers. It is acrylonitrile styrene acrylate, and the difference to ABS is basically just the same properties but with improved weather resistance.
Gotcha. Okay, so we're getting into another technical part now with moulding. Tell me a little bit more about this.
This is our polycast material. It is a material designed for investment casting. This here is what they call an investment mold. So what you do is you take your 3D printed part, you dip it in a ceramic slurry, then you shower it with sand, and then you build up this mold after many dips. Then what you do is you put the whole mold inside a kiln and you fire it at 1200 degrees. And what that does is it cures the ceramic, makes it solid, and it also burns out the polycast.
Right.
So we've developed, the best feature about the polycast is that it burns away very cleanly, has an ash residue of 0.0003%.
Right, okay.
And you can see, you can see the part here. You can see the layer lines on the inside. So you really keep that detail inside the mold. If you look inside the mold here, you see no residue from the from the burnout.
So finally then, Luke, we've got your wall of filament. And how many filaments do Polymaker produce?
Yeah, so currently now we have about 6 PLAs on offer. We have 5 nylons. We have 8 PCs. Got 3 TPUs, some specialty filaments. This is our polycore business. This is pellets.
Yep.
At Formnext, we see a lot of bigger machines, a lot of screw extruders, and the pellet business is becoming larger and larger. So yeah, lots of glass fiber, carbon fiber, even a 40% carbon fiber PC here. And then our PETG, our ABS, and our ASA.
That's amazing. What I really like about the Polymaker brand is that the amount of thought that you guys put into stuff, even things like how much filament do I have left on the spool, and not only that, you've also got all this information, this key core information about industrial applications that can be used on pretty much anything now, which is awesome.
Yeah, so I think in the past people have come to the booth and they've got a great application, they're enthusiastic, they want to know, right, I need a really stiff material. So I thought, okay, we'll take our top 5 performing materials in 4 engineering categories and then list them up so people then can compare them directly. All the data is taken from our TDS, from the lab, all 3D printed samples. So we have Young's modulus, which is a test of stiffness. Tensile strength is a test of pulling apart.
Yep.
Then we have heat deflection temperature, which is we take a sample, we put it under a load, and then we heat it up, and then we measure at what temperature is it deflecting. And then finally the impact strength, you know, how much impact can a part take.
All your blends are made in-house, nothing's exported or used externally?
Everything is compounded in-house by Polymaker scientists. We have at the heart of the company is a research and development lab. All materials start there and then come out of there. So you know, we really put a lot of effort into not only making the materials very printable, but also really relevant to the industries that need them.
That's amazing. Thank you so much again for your time.
You're welcome, Sam.